This chapter is on kinematics, and kinematics just simply means that we're going to be studying motion. We're going to be studying how things move. The next chapter we do after this one we'll be discussing why they move, but in this chapter we're just discussing how they move. And you've already talked, or have already read in the first section of this chapter, that a lot of this originated from studying the planets and from realizing that sometimes the way the planets appeared to move to us on Earth wasn't always accurate because they appeared to go this way for a certain point, and then they appeared to go backwards, and then they appeared to go forwards again. And that really was just because of where we are on the Earth and our position in relation to the position of the planet and how the Earth is moving in comparison to how the planet is moving. And so that all delved into our discussion of frame of reference, which you watched a couple of videos about yesterday, and you come to realize that whether something is moving or not just depends on where you're standing or where you're sitting and whether you're moving in relation to the thing that you're looking at. So all of that has to do with frames of reference. Today we're talking about the difference between distance and displacement. Now, distance means how far you actually, how far your feet actually move. And so distance completely depends on the path that you travel. So if you take a really winding route someplace and then you end up right back over here, you may have gotten a lot of exercise, but maybe you didn't go very far from where you started. But distance depends completely on the path that you actually travel. Whereas displacement depends on your starting and your ending position. Where do I start? Where do I end up? Now, a lot of times we talk about how as the crow flies. And so meaning that a crow or any type of bird is going to go straight from one spot to another, and they don't have to stay along a road like people or cars or things like that do. And so the distance that a crow flies tends to be shorter than the distance that we're going to travel along a road. And so you can almost think of distance and displacement the same way. Distance is going to be how does the road go to get you there. Displacement's more like how does the crow fly and how far did you actually get from your starting and ending position. When you express these two quantities, distance is only going to be expressed with magnitude, how far you actually went, how many steps your feet actually took. Displacement, when that is expressed, includes not only the magnitude or how far, but it also includes which direction that you're going to be taking. So this gets into scalar and vector quantities. A scalar quantity is magnitude only. It only tells us how much. So as an example here, scalar could be something like 3 kilometers. And a vector quantity is going to be both magnitude and direction. So this could be 3 kilometers east. And the terms scalar and vector are words that we're going to be using throughout this chapter because we're going to be using them to describe other quantities besides just distance and displacement. So in the terms of our discussion for today, distance is a scalar quantity. And so what I had here, this 3 kilometers, would be a distance, but displacement would be a vector quantity, and it's going to include not only a magnitude, but also a direction. And so let me see if I can explain to you exactly what that is going to mean here. Come back to this statement in just a second. This example from right here was actually on the first section that you read today. And they said if you start out at your friend's house, and they put that on a number line so that your home is actually at 2, zeros over here, and then the numbers are getting bigger as we go to the right, just as they always do on a number line. So I'm going to go from home to my friend's house, and my friend lives at 7. So maybe that's the house number or something like that, okay? So when you go from your home to your friend's house, how far have you gone? Well, you've gone 1, 2, 3, 4, 5, or 7 minus 2, which is 5 units this direction. And then when you turn around and come home, you're going to take likely the same path, and that's going to be 5 more units this direction, okay? So the total distance that you've gone is a total of 10, and let's say that these are in units of kilometers. So let's say that you've gone 10 kilometers to go from your friend's house and back to your house, okay? So that's your total distance. Your displacement, though, depends on your starting point and your ending point. Well, here's where I started, but this is also where I ended at the end of my journey. At the end of the day, I ended up right back at home. So based on starting and ending point, I didn't have any displacement because I ended up back in exactly the same spot. I may have gotten a whole lot of steps on my phone. I may have, logged a lot of steps for the day, but actually displacement ended up being 0. Okay? So you can see that your distance is always going to be greater than or equal to your displacement. Here, distance is certainly greater than displacement. Now, if I had just gone from home to my friend's house and I'd stopped there, maybe I'm going to spend a couple of days with my friend, then my distance and my displacement would have been the same. But because I turned around and retraced my steps and came back home again, my displacement has come up to 0. Okay? They also gave you an example on the next page of your book that I really want to spend some time going through, because I think if you just try to read it, you may get a little bit confused. So let's see if we can make some sense out of this. Okay, we have a number line, again, that we're going to be traveling along. And they tell us 0's here in the middle, and then positive goes to the right, negative numbers go to the left. That should be very familiar when you've done number lines in math before. And so we start out at 10. And so this is point A right here. So this is where we start. In the first leg of our journey, we go from A to B, and B is at 40. So what is the distance where I've gone? Well, you can see that I'm going to go 10, 20, 30. I'm going to go a distance of 30 as I go from A to B. So what's my displacement? Well, displacement is always calculated taking your final position minus your initial position. So my final position is at 40. My initial position was at 10. So if I take 40 minus 10, then my displacement is going to be 30. Okay, so in this case, you can see that just going from A to B, my distance and my displacement are exactly the same. Okay, now from point B, I'm then going to go to point C. And point C is back here at negative 40. So what's my distance now? Well, my distance from before was 30, and I'm going to add to that the distance from B to C. Well, if I went from 40 down to negative 40, that's going to be a total of 80. So that gives me a total distance that I've traveled of 110. Right? That's how many steps I'm going to end up with on my phone, is I'm tracking how many steps I take for the day. My displacement, though, is, again, my final position minus my initial position. Well, my final position was negative 40, and my initial position at A was 10. So I'm going to take negative 40 minus 10, and that's going to give me a displacement of negative 50. Well, what's that mean? Well, positive numbers are to the right, negative numbers are to the left on the reference system that I've chosen here. So what that means is that my final displacement, if I started here, my displacement is 50 units to the left. My initial displacement was 30 units this way. So really, I had 30 units to the east. Now what I have is a negative 50 or 50 units to the west, okay, from where I started, because displacement's always from where you started to where you ended up. All right, so now let's check one more. The last leg of my journey takes me to point D, which is at negative 20. And so the distance that I had going from A to C was 110. And to get from C to D, I have to go from -40 to -20, which is another 20 units. So I'm going to add 20 units to that, and I'm going to end up with a total of 130. Now you'll notice that distance is always positive because that negative number is really indicating a direction. And so distance is always positive, so I've ended up with a total distance of 130. Okay, now what is my displacement? Well, again, displacement is always measured from where you started to where you ended up. And so where I ended, my final location was at -20. And I'm going to subtract from that this 10, which is where I started. And so -20 minus 10 gives me a -30, or 30 units to the west from where I started. And if you can see, from going from A to D, that would be 10, 20, 30 units. Okay, so again, you can see this to have been played out. Sometimes your distance may be equal to your displacement, as it was when we went from A to B, but the rest of the time, my distance was always greater than my displacement, because as you can see here, a lot of times I went back and I kind of retraced my steps going from B to C and then from C to D. These sections in here are all places where I've retraced my steps. So distance is always going to be greater than or equal to your displacement. Okay, so terms for today: distance, displacement, scalar, and vector. Scalar means magnitude only. That's your distance, and so you'll see that I just have the magnitude, I just have how much. And vector is magnitude and direction, and so you'll see here that I either have a positive or negative sign, or I can actually put it with a direction: 30 east, 50 west, 30 west. And so when you have a displacement, you need to make sure that you get a direction on that as well. Okay, so you will be getting some practice of doing some things in your homework assignment today.